All right, don't want to scare you with all that I've written so far, but just preparing something. We're going to talk about our last section for what I call the first part of chapter 3. These are just our derivative rules. We're going to talk about derivatives of trigonometric functions. And it turns out if you apply the definition of the derivative on these objects, sine and cosine, you're going to get down to these. You can always express it in terms of these limits. One of them is cosine of h minus 1 divided by h. That's the limit as h approaches 0. Notice that appears in the sine derivative and the cosine derivative definitions. We also have this is limit of sine of h divided by sine as h approaches 0. So I do actually want to take a look at those. I want to show you guys what those look like. Now, this is actually a much larger mathematical construction, and I'm not saying that you're not ready for it yet, but a lot of the details sort of blow over your heads. But I think we can all agree, based on these graphs, what is the limit of the red line as it approaches 0? Now, if I actually grab that point, it will tell me it's undefined. But again, I don't care about evaluating, I care about the limit. The left and the right-hand sides both agree we're heading towards 0. For the cosine one, cosine of x minus 1 over x. For sine, limit as h approaches 0 of sine of h divided by h. Note, I had to use x's to get it to graph, but we're ultimately talking about h's. It's undefined in its evaluation, but ultimately I can say quite definitively, oh man, this one's hard to find. The left and the right-hand side seem to agree. The answer looks like 1. Okay, so that's going to allow me to rewrite this is 0 and this is 1. So sine of x times 0 plus cosine of x times 1. The derivative of sine is cosine. And that works out pretty nicely. What about the derivative of cosine? Well, once again, this is 0 and this is 1. Notice cosine, there's a minus sine of x times 1. The derivative of cosine of x is negative sine of x. Now, here is a list of all 6 of them and all 6 of their derivative relationships, in case you want to know. I kind of grouped them together between the positives and the negatives. Notice all of the signs that are negative, they all begin with cosine, cotangent, and cosecant. And there's also some relationships going on the rows. So this is one term. Both of these have square terms. And both of these have 2 terms. So the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared. I just want to do a quick note. When you write something like this, it's telling you you're taking the function secant x and you're squaring it. It's just a way to avoid writing more parentheses. The derivative of cotangent is negative cosecant squared. The derivative of secant is secant times tangent. And the derivative of cosecant is negative cosecant times cotangent. Okay, so most of these you don't have to prove. I'm going to prove one of them for you just because I think it's interesting. But most of what we're going to look at is how do these relate inside of product and quotient rules. And I'll look at a couple of examples like that. So as a reminder, tangent is sine over cosine. And we can use the quotient rule to say that it's the bottom times the derivative of the top. What's the derivative of sine? Cosine. Minus the derivative of the bottom, negative sine, times the top, which is sine, all over the bottom squared. Now, how do we simplify this? Cosine times cosine, that's cosine squared, Minus times minus is plus. Sine times sine is sine squared. And it just so happens, according to the Pythagorean theorem, cosine squared plus sine squared is 1 over cosine squared x, aka what I would call secant squared. So, a lot of these come from understanding the sines and the cosines. And ultimately, the sines and the cosines come from the definition, but it does require these special limits. And these limits are special. They took a long time to prove. We didn't know about them for most of, I would say, human history. But that's actually true for most things. And there's some really elegant proofs in your textbook if you're interested. Or if you'd like me to make a further video on them, I'd be more than happy to. Okay, let's do some examples. Let's take a look at some product rules. So here's a real quick product rule. Let's say 3x squared times the sine of x. Remember, we divide them into their smaller categories. So we have 3x squared, and the power rule tells me this goes to 6x. Meanwhile, for the sine term, we have sine of x, and I know the derivative of sine is going to be cosine of x. And then we just do the product rule. We get 6x sine of x plus 3x squared cosine of x. So really, we're just throwing these in as more things that we can find the derivatives of, if you're interested. Now, I will point out there are some tricky ones that look interesting, but really turn out to be quite boring. One of my favorites is, what is the derivative of cosine times tangent? Now, if you go by way of the product rule, again, we have cosine, whose derivative, is negative sine. I want that blue out of here. There we go. Then we have tangent, and if we just go back to what we just did, we see the derivative of tangent is secant squared. And so, if you do the same sort of multiply, we're going to get negative sine x tangent x plus cosine x secant squared x. Now, here's why this is a little bit tricky. It is because if you think about cosine x times sine of x over cosine x, that should cancel. In reality, this is sine x, whose derivative should just be cosine x. So the question is, how do we get cosine x from this? And this is where simplifying earlier versus later can help you. So, in case you're curious, this is negative sine squared x over cosine x. And that's just because this term is sine over cosine. Plus, secant is 1 over cosine. So this is cosine of x over cosine x squared, which we can rewrite as, get rid of the squared, turn that equal to 1. This is 1 minus sine squared of x over cosine x. Well, what can we rewrite the 1 as? Well, the 1 is sine squared x plus cosine squared x. And sine of x squared times minus sine of x squared leaves us cosine squared x over cosine x, or cosine x. So, this is the problem with trig functions, is that there's a million different ways to represent these functions. So, doing some simplifications on the front end might help you. Just an important thing to remember. Okay, let's talk second derivative. So, as we know, the derivative is something we can do to functions. We can also do something called the second derivative. If y is e to the x times sine of x, y prime is going to be d over dx of e to the x sine of x. If you think about it, this is just a notational note. Y double prime will be the derivative of y prime, which will be the derivative of the derivative of e to the x sine of x. And something happens between these two. We group them together as d squared over dx squared of e to the x sine of x. Now, we don't necessarily have to know how to find a derivative in one step. We're still going to do two steps, but I just want to say this symbol is instructions to take a second derivative. That's ultimately what this is. So I just wanted you to be aware of that notation. Let's actually find it. So this is e to the x times sine of x. I know these derivatives individually. Here's f prime, here's g prime. So the derivative of e to the x is e to the x. Derivative of sine is going to be cosine. So what does the product rule tell me? Multiply the pairs. Is going to be e to the x cosine x plus e to the x sine of x. Now, I might want to simplify this as e to the x times sine of x plus cosine of x. And that's just because now, to find the second derivative, this is y prime. To find the second derivative, I need to take an additional derivative of this term. So, once again, I'm going to label f. And now, this term entirely is g. We're going to get our table going. We have f is e to the x, of course, f prime, e to the x, versus now g, sine of x plus cosine x. And what is g prime? Well, it's just going to be the sum of the derivatives of sine and cosine, which is going to be sine goes to cosine, and cosine goes to negative sine. And once again, we're just going to do the multiplications. We're going to get y double prime, grabbing myself some more room. We're going to get e to the x times cosine of x minus sine of x plus e to the x times sine of x plus cosine of x. Now, this is another important simplification. We have e to the x times cosine x plus an additional e to the x times cosine x. That's going to be 2 cosine x's. And we have a minus sine e to the x and a positive sine e to the x, which goes away. So, in reality, I like to write my constant first. Turns out the second derivative is going to be 2 times e to the x times the cosine of x. Now, this is also tricky to make sure that you don't forget things like where the subtraction goes, where does the 2 go, things like that. But hopefully, this video will help you. Now, when you're done with this section, and I hope you're able to get it done, don't forget there's also going to be a quiz covering sections 3.1 to 3.5. And you must complete at least a 70% on the previous sections, 3.1 to 3.5, to unlock that. So hopefully this all goes smoothly, and I'll see you next week starting on our new lecture series. Have a great one.